Hello everyone, welcome back to the channel. Today we are going to discuss how to draw three-phase waveform and what is meant by phase sequence. So let's get started. In the previous session, we have discussed how these three-phase EMFs are generated. We know that when we place the conductor in a magnetic field, suppose this is the north pole, this is the south pole, and these are the magnetic lines of force from north to south pole. This is the direction. Okay, now we are placing the conductor in this magnetic field. When we place only one conductor, suppose this is the conductor placed in a magnetic field, and when we have a relative motion between conductor and magnetic field, we will get EMF induced in that conductor. Suppose we place two conductors, then what will happen? We get two EMFs. When we place three conductors, we will get three different sinusoidal waves. When we place one conductor, we will get the wave like this, sinusoidal wave like this. When we place two conductors, the second wave will generate, and we place the third conductor also, we will get the EMF, these three EMFs. Okay, in that case, in this way, we generate the three-phase EMF. But observe here, this conductor must be equally apart, so that this value of E1 equals to E2 equals to E3 we will get. When the length of conducting material is same, that means number of turns used for each winding must be same, so that we will get the equal magnitudes of induced EMF in all the phases. Also observe here, suppose this is first conductor, this is second conductor, and this is third conductor. The angle between this first and second is 120 degrees maintained. Second and third also 120, and third and first also 120. That means all the conductors are equally apart, are placed equally apart, so that the EMF induced in that also having a phase difference of this 120 degree with respect to each other. Mathematically, we can represent it as a, suppose we name it as a, if conductor 1, we name it as R conductor, for conductor 2 Y, and for conductor 3 B. Okay, R, Y, B, we have name given to it. Then VR will be, let R is the reference conductor. Then VR will be Vm sin of omega t. In terms of mathematical equation, we can represent that wave as VR equals to Vm sin of omega t, where Vm is the peak value of EMF induced in it, omega is the angular frequency. Okay, now when we write Vy, which is equal to Vm sin of omega t minus 120 degree, because we know that all the phasors are rotate in anti-clockwise direction. So first, if we stand here and observe this conductor, then one will pass first, then after that, after 120 degree, 2 will pass. That means after 120 degree, 2 is passing this instant, this position. So this can be written as minus 120 degree. Vy is lagging behind VR by 120 degree, so minus 120. Again see here, Vb is lagging behind this one by 240 degree, lagging behind this first phase by 240 degree, or we can say it is leading the first phase by 120 degree. In that way also we can write. So this is the mathematical representation of the three-phase EMF induced. When we plot this graphically, this is called as three-phase waveform. This is called as three-phase waveform. See here, suppose this is the EMF induced in first R, this is second, and this is third. For example, we are standing here. Okay, at this position we are observing the wave. Then at this position B is starting, so we will write here B. Okay, now after B, this R, red one is R, this green one is Y, and this is B this, which wave is starting? R is starting at this point. At this point, R is starting, at this point B is started, and after this R, at this point Y is starting. Okay, and what is the difference between these two? The difference between these two is 120 degree. Difference between these two also 120 degree. That means when the second phase will start at 120 degree to the first phase, and the third phase will start at 120 degree to the second phase. So the overall phase difference between first and third will be 240 degree. So after Y we will get R, after we will get Y, again B, again R, again Y. Okay, and the angle between them is 120 degree. 120 degree because they are placed at 120 degree with respect to each other. Okay, now let's see how to draw this EMF, this three-phase waveform. First we will write or draw a reference axis which is omega t. Okay, this is magnitude axis where we are going to plot the three-phase EMF. Okay, now first we will draw the R phase. Before that, first we will take the reference of positive maximum, and this is for negative maximum. This is 0. Okay, now let's draw first phase. This is R phase, so we will draw with red color, and this is continuous. This is for R phase. So this will be the waveform for voltage induced in the R phase. Now to plot the Vy and Vb, first this is 0, so this will be the pi, this is 2 pi instant, this is 3 pi instant. Okay, and this is 4 pi instant, and it is continuous. First we will divide this 0 to pi with 3 equal parts of 60, 60, 60. Each 180 degree is now divided into 3 equal parts of 60 degrees, so that we can draw the remaining 2 easily. Now after R, we know that after R we get Y, and after Y we will get B, and difference between each is 120 degree. So after Y with 120 degree phase difference, Y is starting. After R with 120 degree, Y is starting. So this is 60 degree, this is 120 degree. That means here Y is starting. So draw it. In that, and it is here also continuous. This is the waveform for Vy. This is the yellow phase Vy. Then after Y 120 degree, B is starting. So here Y is started after 120 degree, that means this 60 and this 60. Here B is starting. So draw it. Okay, this is the B phase voltage. B phase voltage, and within this each 2 induced EMF we have 120 degree phase difference. And observe here, all are having same positive maximum value Vm and also same negative maximum value. That means all the induced EMF Vr equals to Vy equals to Vb, all are equal by magnitude only. Okay, in this way we can plot the 3-phase waveform very easily. Okay, now let's see what is meant by phase sequence. The phase sequence the phase sequence of three-phase supply is the sequence in which the three phases reach their maximum positive values. Okay, suppose this is the waveform. This is the waveform where this is the first wave, this is second wave, and this is third wave. After that, first, second, and third is because this is continuously generated. So when we observe here, suppose we are standing here at this point and observing this waveform. At this point, we are observing the first will pass, the second will pass, then third will pass, again first will pass, second will pass, third will pass. That means at the first, second gets its maximum positive value. Okay. Then at the last, the third is getting its positive maximum value. Okay, and this is the sequence, and that sequence is known as phase sequence of three-phase supply. That is known as phase sequence of three-phase supply, and it is indicated by RYB. The phase sequence, normal phase sequence we use is RYB. Again, after B, R is repeated. RYB, RYB, RYB. In this manner, RY, then B, again R, Y, B, again R in this way. This is the phase difference, normal phase difference we use. Suppose instead of Y at the second, if we get the B, the phase sequence will be R, B, Y, R, B, Y. This is the phase difference. This is called as negative phase difference. We use positive phase difference. Okay. And what is the importance of this phase sequence? This phase sequence determines the direction of rotation of motor. Suppose we are supplying a three-phase induction motor. In that case, if the phase sequence is changed, the direction of rotation of motor will change. Suppose we have this type of application. In the factory, we are using mostly three-phase induction motor. Okay, and this three-phase induction motor is running this conveyor belt. This is conveyor belt. And these water bottles are filled and capped at this position. Suppose at this B position, it is filled and capped. And the direction of conveyor belt is like this when the normal phase sequence is applied. When RYB is applied, the direction of induction motor is such that the conveyor belt will move from this A position to B position. What will happen if this direction is changed, if this phase sequence is changed, if by mistake this phase sequence is reversed, that means it becomes now RBY. Then the motor will rotate now not in this direction, opposite to that. That means the direction of motor is now reverse. So conveyor belt will reverse its direction also, and from B to A. Now conveyor belt is moving from B to A. What will happen? The filling and capping of this bottle cannot be done effectively. Okay, this is the problem with reversing phase difference. So always the phase sequence should be normal RYB is maintained. Okay. This is all about how to draw the three-phase waveform and what is meant by phase sequence. In the next session, we will discuss types of load according to the connection and according to the condition of balance. Okay. For that, stay tuned and keep learning. Thank you.